Hi everyone, I wanted to share something really cool with you. Nowadays there's so much technology at your fingertips, why not use it, right? So I want to show you some common commands. I like to think of it as things I wish that Wolfram Alpha would do for me, and it will. So notice I've signed up for a trial version of the Wolfram Alpha Pro, but I'm sure if you have the app on your phone or iPad it would do the same. I haven't tested that out yet, but so in class we're talking about right endpoint method, basically using finite areas to approximate the area under a curve, and we've talked about left endpoint method, right endpoint method, and midpoint rule, etc. Let's talk about what to command Wolfram Alpha to do. Look at my command there. It says integrate y equals x squared over 0 to 1 using left endpoint method. So let's take a look. Notice what it does. It says here the result is 0.24 using 5 intervals. That means that it did 5 partitions. This is exactly like the one we did in class, except I think I used 4 partitions. But down here there was a button that said show interactivity. On the Pro version you can do interactivity. So here I have 1, 2, 3, 4 partitions using the left hand rule. And I'm going to highlight this here. Let me put it on pen. Okay. Okay, notice here the result says 0.21875, and you probably can't tell from the drawing, but that last rectangle has 0 area, so there's actually 4 partitions there. If you look back on an example that I did in a prior podcast in class, we did this same thing where we looked at y equals x squared, and we looked at partitioning 4 partitions and the left endpoint rule. We did this by hand. Well, it's great to have Wolfram Alpha to do it for us, and check out these other cool buttons here. Left hand, right hand, and midpoint. Now I'm going to hit right hand. Notice now it draws the right endpoint is touching the curve, so that's an over approximation, 0.46875. Like I said, we did the same exact example in class, but we had to do it out the grueling hard way, right? And then it even does the midpoint rule for us, so where you're noticing the midpoint of each rectangle and the result of that, 0.328. And what we said in class was that, gee, that one is awfully close to 0.33, which is the true area under the curve. So what's really neat about Wolfram Alpha, if you page down, it tells you the exact result, so it's telling you the true area. I'm going to highlight here, I just noticed my pen was turned off. So it's telling you the exact result, true area under the curve, which in our very near future we're going to know that's the integral over the certain bound, in this case 0 to 1. But you can also play with the left hand, right hand, and midpoint rule. And then another really great thing, we haven't talked about Simpson's rule or trapezoidal rule yet, but I love this feature. If you keep paging down, look at that. It's going to give you the results. Again, this is using 5 intervals, though, using various rules, Simpson's rule, trapezoidal rule, etc. So, one thing I really wanted to show you is notice, let's go back to left-hand rule. What we said in class is if you use more and more rectangles, watch how that number changes. Look at that. I'm using more and more partitions, thinner slices, getting closer. And notice how I move that slider all the way over. And what's happening as I move it all the way over, now you're seeing, look at that. It's getting, let's see if it'll let me highlight it. It's getting closer and closer and closer to the true area. Okay? So I just like that interactivity feature and wanted to show you that. Now's a good time to talk about a couple other common commands in Wolfram Alpha that people are, I think, afraid to use, but they're great. We've been doing a lot with finding absolute extrema, so I just copy and pasted a few commands here just so you'd know how to write them. If you tell Wolfram Alpha to do this, it'll do it. Let's try. So I typed in find absolute extrema of a certain function. Find absolute extrema for y equals x squared minus 4, and then I wrote 0 is less than or equal to x, less than or equal to 3. So we're finding absolute extrema over those bounds. Just hit enter. And what's neat about this is it not only, should tell you the answer, it usually shows you how to do it. Let me hit pause as it's thinking. Sorry, I was having some connectivity issues there. It was just my internet was down. So anyway, I have the command written in there. Let's see what it does for us. There we go. So it says that it's searching for absolute extrema, and what I really like about this is not only will it tell you where the extrema are, it will tell you whether it's a global max or a local max, something like that. So you'll see here, look at the language, global max meaning absolute max. So it's telling you, at x equals 3. Okay? And again, that's for the function y equals x squared minus 4, but you see how I typed it in there. So it's telling us there's a global max at x equals 3, and it's telling us that there's a global min at x equals 0. And then it's even graphing it for us. Okay, and remember we had talked about, I wanted to mention, we had talked about when you put the domain restriction from 0 to 3 like that, you have to test the endpoint, so you're really kind of chopping the function and just looking at it, from here to here. So it makes sense that those, you have to test critical values, of course, but you also test your domain endpoints to see whether that's where the local or global max occur. Okay, another command, so I really just wanted to spend some time playing with Wolfram Alpha with you. Another, I think, useful command is, how do I graph a piecewise function? A lot of even algebra students struggle with this, but the main thing is, look how I typed it in. It's all, in Wolfram Alpha, it's all about how are you going to type something in, or else it won't recognize. So notice all the bracket, curly brace, x plus 3. So this translates to x plus 3 where x is less than 2, and x squared where x is greater than or equal to 2. Let's hit enter. And what's neat is however you type it in, you'll know if you're right, see, because you'll know if it accepted what you wrote, because it'll put the input over here. Say, yeah, that's what I was trying to say, right? So you do have a piecewise defined function. And then the nice part is it's going to graph it for you right here. So, then you're able to investigate discontinuities, such as we were doing at the beginning of the term. So we see there's a jump discontinuity there. Okay? So that's just, a lot of people have a tough time graphing piecewise, so I just wanted to show you the command so you could, lean off of Wolfram Alpha to help you graph if you need to. And let's look at another command that is very important, especially at the beginning stages of calculus. Hey, find the equation of the tangent line. How many times were you guys asked to find the equation of the tangent line to a curve at a certain point? A lot at the beginning. So let's take a look at that command. Okay, and I'm just going to, this is find the equation of the tangent line to y equals 3x squared minus x, but like I said, you could type in any old function and then at a given point. And I didn't tell you this, but not only does it give you the result, there it is, the equation of the tangent line, and it even it draws you the graph. There's the actual equation of the tangent to the curve at the given point. Usually it asks, well, here it's not. On the app, if you have the app on your iPad or your iPhone, it will say, do you want to see how this is done? And that's the beauty of that. It shows you the steps. And the last command I want to look at is differentiate implicitly. Okay, so what I did was I had typed in differentiate, y squared Basically the function was y squared minus 3y minus 2x equals 7, and I told it to differentiate that implicitly, right? So it interprets the input and it spits out a result. But notice over here, this is what I wanted to show you on a lot of the apps, or if you just sign up for the pro version, step-by-step solution. So this is like for 2 o'clock in the morning when you don't have a friend to help you on your calculus. You know, you use this. And it's neat because it differentiates the left side of the equation, differentiates the right side of the equation, derivative of 7 is 0, and you can go step by step, such as I just hit right there. It's thinking. See, and I can keep hitting next step, and it's differentiating each term in there. And it really writes it out rather formally. A lot of people say, wow, you know, I wish I had all the steps to the problem, and it does. It takes it probably even more formally than I would write out all the steps. So I just wanted to show you that. It's a nice help. Okay, hope that helps. Good luck with your wolfram alpha investigations.